Pascal's triangle. This one actually is kind of fun. Okay. So right now we're going to make a triangle of numbers. We're just going to have a bunch of numbers written down on paper, and we're going to use a very simple rule. Start with the number 1. So write down a 1. And you enter new numbers diagonally down to the left and down to the right of every number. And you do it by the following rule. Every number that you enter is the sum of the two numbers above it. And by the two numbers above, remember we're sort of working on diagonals, so it's diagonally above to the left and diagonally above to the right. So, how does this go? So first you just have 1. Now you have to do a number diagonally down and diagonally down left and diagonally down right. So there's nothing to add, so there's nothing to add except the one that's above it, so you get 1 and 1. So what goes below the first one? Well, below left, you just have the 1 added to nothing, so it's just 1. Now what about from the first one diagonally down to the right? You've got a 2 because what numbers are above it? 1 and 1. And then on the end you have a 1. Does that make sense so far? Okay. So now what about in the next row? Right. So on the corner on the end you're gonna have a 1, and then what's the next number? 3, which comes from 1 plus 2. And the next number is going to be a 3, and then the last number is a 1.
But why is it 3 and not 4?
Huh?
Why is it 3? Aren't you adding all the numbers in the line?
No, you're adding the numbers that are above it. So this 1 comes from this. So for example, where does this 3 come from? It comes from the 1 and the 2. The two numbers diagonally above it.
The 2 comes from the 1 and 1.
Yes. Okay. So notice that at the end of every row you're always going to have a 1, because it's always going to be a 1 plus there's nothing there. Does that make sense? Okay. Yeah. So let's make the next row together. What's the first number? A 1. Next. 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 And we're done. We're done with that row. Okay. So does that make sense? Okay. You want to do one more row? Okay. Next row. Okay, so is that a fun game? Okay, can we do this for as long as we want? Okay. That's very nice. So what? Well, let's now calculate every combination number. Okay. So, 0 choose, let's first do 0 choose 0. Now, excuse me. Now in order to do 0 choose 0, I have to tell you something. 0 choose 0, this is going to be 0 factorial over 0 factorial. And that might seem incredibly perplexing. So a little fact that I have to give you is the fact that 0 factorial equals 1. Now we're going to take this as a fact. Using some higher mathematics, you could justify this, but that's beyond the scope of this class. So for our purposes, because normally you would say whatever the number is, count down to 1, but you can't count down from 0 to 1. So for our purposes, we're just going to define 0 factorial equals 1, and we just know that. You dig? Within the context of this class, no. Okay. I can give you a sort of explanation. The sort of explanation is remember what, think back to that's not a good way to say it. Imagine that you have 3 objects. How many ways are there to arrange them in order? Well, how many choices do you have for what goes first? And then 1. So how many ways are there to arrange 3 objects? It's 3 factorial. So now you could say how many ways are there to arrange 1 object? It's just 1 factorial, which is just 1. So the next thing you'd ask is how many ways are there to arrange 0 objects? So now you could have a debate about this. You could say, well, there's no ways to arrange it. Or you could say there's only 1 way to arrange it, you don't do anything. So that's a half explanation for why we take 0 factorial to be 1. But it's kind of unsatisfying, as I can tell by the smile on your face. Okay. So within the context of this class, that's the best explanation I can give. You need to know some higher mathematics and do some fancier things in order to really show where this calculation might come from. Okay. Anyway, for our purposes, long story short, 0 factorial equals 1. Okay. So 0 choose 0 just winds up being like 0 factorial, so it's just 1. Next. 1 choose 0 again winds up being a bunch of 1 factorials and 0 factorials, so that's just going to be 1. Now 1 choose 1 is going to be 1 factorial over 1 factorial again, so that's just 1. Now 2 choose 0. I actually want to write this out precisely. So 2 choose 0 is what? 2 factorial divided by 0 factorial, and then 2 plus 0 equals 2, 2 factorial. You can see the 2 factorial and the 2 factorial cancel. 0 factorial is just 1, so this just winds up being 1. Now what is 2 choose 1? Well, 2 choose 1 is going to be 2 factorial divided by 1 factorial, and then 2 minus 1 is 1, so that's just 1 factorial. So it's just 2 over 1, so this is just 2. And then finally you have 2 choose 2 factorial. So 2 choose 2 is 2 factorial divided by 2 factorial, and then you also have 0 factorial. Cancel, cancel, that's just 1. Next, 3 choose 0. Well, 3C0 equals 3 factorial divided by 0 factorial, and then 3 factorial. So what happens? Cancel, cancel, this is just 1. Now we have 3C1, so let's see, 3C1, what's that? You get 3 factorial divided by 1 factorial, and then what's left? A 2 factorial. So what do you get? Well, 3 factorial is 3 times 2 times 1 divided by 1 factorial is just 1, 2 factorial is 2 times 1. So what happens? Cancel, cancel, you get 3. So 3C1 is 3. Similarly, 3C2 is also going to be 3, and 3C3 is going to be, everything cancels, it's going to be 1. I can keep going. What do you notice? It's the same thing as Pascal's triangle. So somehow there's this extraordinary connection between making this triangle using these rules just by adding numbers together and doing combinations. And if you wanted to talk about and understand those connections more closely, you could take a course in number theory and combinatorics. The only thing I'll say is, so what does this tell us and how can we use it? If you want to find an entry in Pascal's triangle, you can just do a combination. Or vice versa, if you already have Pascal's triangle, if you want to find, for example, 7c5, just look in Pascal's triangle and it's right there. Okay. So that brings us to an end.